Hi, let's go on to do calculation for sound and echo. After I've explained each question, you can pause the video for a little while then students can then try out the question first before we go through the answer. All right, but you could also just show the answer for the first few questions, and then the subsequent ones will give time for the students to do. So let's get started. Now, this first question is talking about a flash of lightning. So if you have a flash of lightning, of course, then you will hear the sound of thunder, and the thunder is heard 3 seconds later. The speed of sound is given to you 340 meters per second, and you are required to calculate the distance. Now, do bear in mind that all the calculation questions in this chapter make use of this formula that distance is equals to speed times time. Sometimes they will give you the speed and time and you're required to find distance, or distance and speed and you're required to find time. But basically, if you know this formula, you'll be able to do all the questions that follow. Okay, so this is where you are, and you can hear the sound of thunder 3 seconds later. So you can hear the sound 3 seconds later. Now, this is not an echo question. I repeat, this is not an echo question, because an echo question, the sound will be reflected back. So this is a very direct question where the sound just travels from one place to another, in this case from the lightning to the listener's ears, the observer's ears. So in this case, how do we do the question using this formula? You can pause the video and then you can give it a try. So there you are. This is the answer. The distance, the question asks for distance, right? So distance is speed times time. This is the way we want you to present your answers. Always make sure that you have the formula written out, speed times time. And the speed is 340. That means in 1 second, it travels 340 meters. And in this case, it takes 3 seconds. So the distance is 1020 meters. So this is the answer. So let's go. You may want to look at your own working to make sure that you have written down that you are calculating distance. You have written down the formula. You have shown the calculation, so the substitution, and your final answer comes with units, right? So the unit is in meters. Right, let's go on. The second question, a man stands at one end of a long hall and claps his hand. He hears his echo after 4 seconds. Take note, this is hearing your echo. And the length of the hall is given, and you are asked to calculate the speed of the sound. So you hear after 4 seconds, the length is given, and you are asked to calculate the speed of the sound. For questions like this, it will be very helpful if you draw a simple diagram. In this case, the diagram is drawn for you, but it will still be very good for you to just draw some lines. So the man sound is going to hit the wall, and then it comes back to him, and then you can hear it as an echo, right? So which means in total, sound actually travel 660 meters towards the wall, and then another 660 meters to go back to the man. So take note that in this case, the distance is 660 times 2. So based on the formula that we were looking at just now, in this case, this is asking for the speed, right? So do you remember what is the formula for speed? Speed is distance divided by time. So based on this formula, are you able to calculate the speed? Take note the distance based on this diagram, and take note that he hears the echo after 4 seconds, which means it will take 2 seconds. It will take 2 seconds to travel to the wall, and it will take 2 seconds for the sound to come back. All right. So you may pause the video for a while to try to calculate the distance. So this is the answer. There are two ways of doing this question actually. You can, because we know that speed is distance divided by time. So what you can do is you can take the total distance traveled by sound, which means 660 plus 660. So this is the total distance, right? So 660 meters plus 660 meters. So the total distance is 1320, and you can divide by the time. The total time is 4 seconds because remember, 2 seconds to travel to the wall, 2 seconds to come back. So after the sound is produced, 4 seconds later you hear the sound. So total distance divided by the total time taken. So that's the answer. Some of you may actually do it another way. So you will say that speed is distance divided by time. So you may choose, actually if a diagram is drawn, it's quite clear, you may choose to take one of the journey. So you may choose to take 660 and then you divide by 2 seconds, because you know that to hear the echo is 4 seconds, that means one way is 2 seconds. You will get the same answer as well. Please remember your units meters per second. Oops, there's a wrong unit here. It should be meters per second. You will get the same answer. All right, so both methods are fine. Let's go on to the next question. Question 3. The sound from the loudspeaker. So you have a loudspeaker here. It bounces off a wall. So I have a wall. You notice that I'm actually drawing a diagram. As I've said earlier, a diagram really helps you to visualize, and it also prevents you from making careless mistakes. So the sound the sound from the loudspeaker bounces off the wall and it reaches the loudspeaker 1.2 seconds after it's transmitted. So the sound is transmitted, hit the wall, come back. The entire journey is 1.2 seconds. So what you can then do to help yourself is to write down, therefore, each journey takes 0.6 seconds, right? So to and fro is 1.2 seconds. So one way would be 0.6 seconds. So I'll write this information down. And the speed of sound is given to be 330 meters per second. The question asks how far. Now, when we say how far, we are actually asking for distance. But take note, are we asking for the total distance that the sound travel, or what? In this case, say how far is the speaker from the opposite wall, which means I'm interested to know this distance, not how far the sound has traveled, because how far the sound has traveled would be from here and back, but I only want to know from here to here. So with this diagram and the information, you can pause the video and give the question a try. Okay, right. So just now we mentioned that the loudspeaker is here and it traveled to the wall and come back. Each journey is 0.6 seconds, right? And the speed is also given. So again, based on the formula that we want to find the distance. Yes, so we are trying to find the distance, this one. So I know this D is what I'm trying to find. Okay, draw a simple diagram like that on your paper. So distance, again, is speed times time. The speed of the sound, it doesn't matter whether you bounce off the wall or not, the speed of sound remains the same value. So it's 300 in this case. Use the value that is given in the question, okay? So 300. So 300. The time, well, in this case, this working made use of 1.2 seconds. They use the time that the question has given, so 1.2 seconds, and then you will get an answer of 360 meters. Now take note, if the time that you use is 1.2 seconds, which means it's the total time taken by the sound to reach the speaker again. This value that you're calculating is actually the distance from here to the wall and back. But since the question only wants you to find the distance from the loudspeaker to the wall, I will then divide the answer by 2. Similar to the previous question, it is perfectly alright to do it this way. Okay, there's another way. You can say distance is speed times time. And the speed, again, no change. So if I want to know the if I want to know the distance from here to here, okay, just one way, if I want to know the distance from here to here, then I only need to know the time needed for the loudspeaker to travel from here, the time needed by sound to travel from the loudspeaker to the wall, and in this case 0.6. So that's another way I can do. I find this more convenient because then my final answer I don't need to divide. So 2 methods. So by now you would have noticed for questions on echo, although the formula is simple, something that you are probably familiar and been using since primary school, but you have to be very careful about the substitution of distance and time. Are we talking about the time for the whole journey? Are we talking about the time for one direction? So read the question carefully, and that's why it's important for you to draw a diagram. Okay, let's go on to the next question. This is a very, very typical question where you have a sheep and then you transmit a pulse of sound. Remember in the previous slides, we said that this is an ultrasound, and then the chip, of course, the sound will bounce back, and the receiver receives the sound. Oh, sorry, this is from fish. Okay, so let's make it a big fish. Okay, so the receiver will receive this reflection of sound after 0.8 seconds. 0.8 seconds. So if I draw my diagram, I would take note that 0.8 seconds is the time taken from the time I transmit to the time the sound comes back. That is 0.8 seconds, which means each journey is 0.4, right? The speed of sound is given to be 1,200. How far? How far? That's my question. Again, this means the question is asking me to calculate the distance between the fish and the sheep. So I need to know this distance over here from the fish, this distance over here. Okay, so give it a try and see if you could get the answer. Okay, so this is the answer. The distance traveled by again, the question asks for distance. So distance is speed times time. The speed of sound is 1,200. 0.8 is actually the time taken. Take note now, the sheep is here. 0.8 is the time taken to travel from the sheep to the fish and the fish to come back. So that's 0.8 seconds. And when I get an answer of 960, it is actually the total distance traveled by sound from here to here and back. But if I only want to know how far is the sheep away from the fish, I will then divide by 2 because I only want to know this distance, right? 960 is actually this plus this, come back again. So 480. Similarly, you could do it by taking one, I will still want to write down the formula. Speed. So I could use 0.4 seconds. Why? Because 0.4 seconds is the time taken from the sheep to the fish. And I want the distance from the sheep to the fish. So you will get this same answer. Both methods are fine. Okay, take note of the units, please. And final question. Final question, no hints? Maybe you'd like to give it a try before we take a look at the answer. Okay, so this is again another question that involve the sheep. Sorry, that involves the sheep. So the sound wave travel downwards and is detected by a microphone. So of course, this is down, up. The speed of sound is given 1005. The previous question, the speed of sound is 1002, this is 1005. Well, it depends on the kind of water, so the speed may vary. Okay, the depth is 2 kilometers. If you are a physics student, you will be very sensitive to units, and you know that this is kilometers, and we should convert to meters. Okay, how long does it take for the microphone to detect the sound after transmission? That means if the microphone is here, if the sound is produced here, it goes down and then come back up again. So how long does it take? That means I want to know the time taken to travel down and then to travel up, right? So the total distance that the sound has traveled will be 4,000 meters, because the depth is 2,000, so that's 2,000 2,000 meters, and then another 2,000 meters up. So total distance is 4,000 meters, and the time will be distance divided by speed. So distance is 4,000, speed of sound is this, so this is the time. Okay, so take note, in this case, this question asks for the time taken from the time the sound is sent downwards until the time the sound is detected. So the sound would have traveled 4 kilometers or 4,000 meters in this case. Right, we've come to the end. So please go back and do the questions in your worksheet on the section of echo. Okay, and the deadline will be the next time I see you. All right, so have a good day. Thank you.